All right, looks like we're ready to go here. Again, like I said, I'll put all these videos up on YouTube and I'll make links to them. Yesterday we had begun talking about naming binary ionic compounds. And we said that binary ionic compounds are those compounds made up of just two elements, like, for example, magnesium chloride. Okay? And I said yesterday, let's not worry about the transition metals yet because they get more than one charge. Now, I'm going to tell you, yesterday I gave you a list, for group 1, all their charges, group 2, their charges, some other elements like zinc and silver and copper, or zinc and silver and aluminum and their charges, and we talked about the anions that came from the nonmetals and their charges. So it's like I said, list them on your periodic table so you don't forget them. So that way I could say, hey, what's the formula for barium fluoride? And you can go and say, well, barium. I'm going to make sure I'm getting the things in my video here. You can go to the periodic table, say barium's in group 2, so I know it gets a +2 charge, and fluoride is a halogen, gets a -1 charge. These charges never change. Like I said, you're never going to see a barium +1. You're never going to see a fluoride -2. So then the formula would be BaF2 because you want two negative charges to cancel the +2 charge. That should be easy enough. And naming them. Don't forget, fluorine changes to fluoride. They all change their name to IDE, I-D-E at the end. Okay. Now let's talk about these mysterious transition metals that get more than one charge. So, transition metals, let's say I ask Dylan to go back and get me the copper chloride. And he sees two bottles back there, CuCl and CuCl2. And I just say, hey, no, get me the copper chloride. You're looking, and one of them is copper chloride, and you say the other's copper chloride. Now, copper is a transition metal. The transition metals are those metals in the fourth period and down in the center, and most of them can get more than one charge. The only two exceptions are silver and zinc. So, in this case, we have to figure out how can I come up with a name to differentiate between these two. And how do I know the charge on the cation? Because they can get more than one charge. Well, I'll tell you what, you know the charge on the anion. Because the charge on the anions, they never change. What is the charge that chloride gets, if you look at the periodic table? -1, right? So if I've got CuCl, that's -1. What does that have to be to cancel the -1? +1, yeah. So the copper has to be a +1, and the chloride is a -1. Now look down here. I've got two chlorides, each one with a -1 charge. So what does the charge on copper have to be in this compound? +2, yeah. Are you seeing that, Kennedy? Yeah, seeing it? Carla? Good? Everyone? All right, wonderful. Now, how do we name these things? Because they're both copper chloride, but we have a trick. Not really a trick. We have a method. CuCl, CuCl2. It's going to be some version of copper chloride, but we somehow have to indicate the difference in the two compounds by their charges. So we call this one copper, and then we put parentheses down. And whatever the charge is on that copper, we figured that out. That's -1, so that had to be +1. So what we do is we put a Roman numeral 1 in there. And then we write chloride. So I would say, hey, Wyatt, I need the copper 1 chloride. You say, okay. I'll go back and get it. Down here, what do you think we're going to put in that parenthesis? 2. Roman numeral 2. Now, a couple things to be that confuse students. I've seen this time and time again. They'll put a 1 in there, and they're somehow thinking it refers to the anion. No, it refers to the charge on the cation. Okay. So this, whatever's in the parentheses, only has to deal with that. And the way we get that is by looking at the charge on the anion and the chemical formula. So that's pretty easy to do. Let's take a look at a couple of other examples, and maybe you could tell me the names of these ionic compounds. How about I look at, chromium's an interesting transition metal. I can have CrCl3 and I can have CrCl2. Those are two different chemical compounds. Chromium, well, you tell me, what do you think we're going to call this one? Chromium chloride, but that's chromium chloride too, right? We need the parentheses. That's part of the name, right? So I'm going to write chromium chloride. Now, what charge does chloride always get? -1. How many do I have? So what do I need the charge to be here to cancel that -3? +3. Okay. So what am I going to put in here? 1, 2, 3. There you go. So this one should be a cinch now. Yeah, 2. Exactly. So that's how you name transition metal compounds. Look at the charge on the anion, and then look at how many there are, and that has to be the charge. One more for you to practice. Let me make it a little trickier, a little bit trickier. How about let's look at these two. I've got two versions of iron oxide. So you tell me, with the parentheses, how to name each of these. Go ahead, take a minute or two and try to figure it out. First thing I said, look at the anion. Well, no, but because look at oxide. What charge does oxide? Yeah, -2. So what am I going to put in front? Roman numeral 2. Yeah. So iron 2 oxide. Good. Now, what about this one? Beautiful. There are two ways to look at this. You could think, okay, my oxygen here, my oxide rather, has a -2 and I've got 3 of them. So that's -6. I have to cancel that -6. So 2 times something will give me a +6. +3 times 2 gives me +6. So I'd say, well, the iron has to be in the +3 oxidation state. Another thing you could do is just say, hey, in these oddball ones, you could put that number up there, that number up there, and you're thinking in your mind that has to be a +3. Each one has to be a -2, and then you'll automatically know. So it's not bad. Just take some practice. All right. I want to introduce an idea, and then I'm going to give you some problems to look at. They're not too bad. I have to talk about something other than binary compounds. Now, if all we did was study binary ionic compounds, there wouldn't be much chemistry to work with. So we have other types of anions called polyatomic anions. And in chapter 2 in your book, there's a table. I forget what page it's on, maybe like 50-something. And they give you a whole chart of these polyatomic anions. So let's take a look at a few of them. First of all, what are polyatomic ions? There's also a polyatomic cation. There's only one of them, but we'll talk about that as well. Let me just call, as a matter of fact, this polyatomic ions. Poly, meaning many. Okay. So, you may have heard of things like sodium hydroxide. Sodium hydroxide. You're thinking, well, we just learned about these chemical compounds. I don't remember learning about anything called hydroxide. That's because hydroxide is an polyatomic ion, and it has the formula OH, a -1 charge. This grouping of the oxygen and the hydrogen, they stick together, right? They're BFFs. They don't break apart. They act as one unit, and that one unit has a -1 charge on it. So, if I was going to write sodium hydroxide, well, we know the charge on sodium. Sodium is always going to be a +1. So, the formula would just be NaOH, sodium hydroxide. The key to recognizing these things is to look at this and recognize that there's an OH here. This is a cation, so it's got a positive charge. So this part of it you're going to have to learn is a polyatomic ion. And again, we have charts that you can look at. Pitfalls. Where do students fall in? Where do they make mistakes? I'll put something like this on. They'll forget to identify this as a polyatomic ion, and they'll call it something like sodium oxide hydride. They'll make up some weird name trying to incorporate every element when that thing just has a name. And the great thing about polyatomic ions is they don't change their names, like fluorine turns into fluoride, oxygen turns into oxide. The name that is on the chart is the name that you use. So, that's all fine and dandy for sodium hydroxide. I want to show you something, though, with a cation that is not a +1 charge, and how we write these things. If I have magnesium ion, gets a +2 charge. Now, hydroxide, I just told you, has a -1 charge. So you treat this just like you would treat chloride or fluoride. -1 charge. So how many hydroxides do I need to meet up with the magnesium to cancel? 2. Excellent. Now, we have to somehow indicate that there are 2 of these. And you know that we use subscripts to indicate the number of ions. So, I could write this and put a little 2 down there, but that's wrong. Because that 2 only refers to the H. So this would be some weird magnesium, like with an H2O on it or something. We can't have that. So we want to show that there are 2 of this unit. So we put parentheses and a little 2 down there. That means I've got 2 hydroxides, 1 magnesium hydroxide. You just have to show that they're grouped together. Okay. So grab your book and let's take a look at the polyatomic ion chart. So chapter 2, and it is on page, I'll tell you right here, page 44. So table 2-1 on page 44 are your common polyatomic ions. I'll do another 1 or 2 for you, and then I'm going to give you a worksheet and let you just play around a little bit. and see if you can name some of these compounds. And again, the only way you get good at this is to practice it. So some very common ones, probably the ones that you'll want to learn right off the bat, are things like SO4 with a -2 charge. This is called sulfate. NO3 with a -1 charge. That's nitrate. We already learned OH, that's hydroxide. And let me see, PO4 with a -3 charge, that's phosphate. So, for example, if I'm writing the formula for sodium sulfate, okay, let's do that one as an example together. And all of these are kind of the same once you start. Sodium gets a +1 charge. We already know that that has a -2 charge, so we have to put a 2 there. SO4, sodium sulfate. Don't do this. I've seen people do this. They put parentheses around the sodium. No, you don't have to. Sodium's a sodium. You just put a little 2 down there. You don't need parentheses because it's not a little group of things stuck together. So, and again, if you have transition metals, you have to play the same game of trying to figure out what to go into the parentheses, what Roman numeral. The last thing I'm going to tell you before I set you to work on this, and you might struggle a little bit at first, but that's okay. I want you to try your hardest, and then we're going to go through and talk about all these things. But let's say, for example, I give you a chemical compound like this. And again, this is a mistake I see students make, and I don't want you to make it. I just say, for example, I put KCl. Remember, potassium is not a transition metal, so never, never, never write this for a name. That would be wrong. The only time we use parentheses is if your cation can get more than 1 charge. Potassium will never get more than 1 charge. Calcium, you would never write calcium 2 oxide, because calcium always gets a +2. So you don't want to be redundant in that. So these are just some things that you don't want to do if you're coming across main group metals. So I'm going to ask you to turn to page 44 and work together and struggle a little bit until you get it. Then we're going to go over it and have some fun. So we'll be putting this up on YouTube. Bye.